So following that advice that you have to learn to walk before you learn to run, let's get used to just making the transition from x over to u. So this first part of these examples that you have in your notes, that's all we're interested in. We're not going to actually solve the definite integral. We just want to transfer from the x out and the u in. And once we can become good at that, then we can start solving the whole definite integral, in essence going from soup to nuts and getting the entire definite integral down to a certain number. Okay, and this is actually good practice because quite often on the AP exam, they're going to give you a question where they're not interested in you actually solving the definite integral. They're going to ask you, okay, here's a definite integral. It's pretty messy. It involves x. What will it look like if it involves u? And then they give you 4 options, and you want to make sure that you choose the correct definite integral. So when we go ahead with example number 11 here, we see that we have 5 times the quantity 5x minus 1 to the 4th power. And we're told, let's use u to be what's the inner function, which is quite often what we're going to do. It's actually not quite often. It's always what we're going to do. Our inner function here is 5x minus 1. We're told that u is going to be equal to that. All right, so u is 5x minus 1. Okay, and once we have u, then we can automatically get du because we're just going to derive u. So the derivative of u, well, what's the derivative of 5x minus 1? That's just 5. Right, so we have 5 dx. Okay, and lo and behold, there they are, the 5 and the dx. Hey, isn't that great how it works out? Seems to do that every single time with these problems on the exams. Okay, so we're good as far as u and du are concerned. What does that mean? Let's start to rewrite our integral. Okay, so we have our symbol. I'm not going to write the bounds yet, because remember, I've got to change the bounds as well. They're one of the 3 things that we have to change. All right, so the 5x minus 1, that's going to be replaced by u, and then we have to the 4th power. Okay, the 4 was never touched there. That's got to move itself down. It's not part of the u and x transfer. Okay, the 5 and the dx, they sub out, and the du subs in, since they're equal to each other. So we have u to the 4th du. What we don't want are the same bounds of 1 and 2, okay? Because those are bounds in terms of x. This is x equals 1 to x equals 2. Some people actually write the x's in their bounds just to remind themselves that, hey, those are our actual term, we're in terms of x. We want to be in terms of u. How do we change that? Well, here's our conversion from x to u. U is 5x minus 1. So if I want my new low bound, well, when x is 1, what's u? We're going to plug 1 in for x. Oops, minus, there we go. We have 5 times 1 minus 1, or 4. That's our new bound for the lower bound. As far as the upper bound is concerned, x was 2, so we're going to plug the 2 in for x. We get 10 minus 1. So our new upper bound is 9. This is our final answer. We've converted the 3 things over, u, du, and the bounds. Once we've made those 3 conversions, we're good to go. Now we're not going to go any further for these problems, but we will on the backside. Let's get a little more practice with our subbing. With number 12, we see here that we're told that u is equal to 9x plus 2. That is our inner function. All right, so we need du. Quickly derive 9x minus 2 and get 9 dx. We've got the dx. We don't have the 9. So what do we do from the previous lesson? Yeah, we're going to put the 9 in, and we're going to counterbalance it with the 1/9 outside, so that we've technically only multiplied by 1. All right, now we can start to rewrite. We still need that 1/9 out front. Instead of having 9x plus 2, we're going to have u. But both of them are still being cubed. The 9 and the dx, they're equal to du, so we make that swap as well. Du is in its place. This is good. Everything's in terms of u. There's no x's left as far as our integrand or differential are concerned. We also need to change our bounds. We're going to plug 0 and 1 into our x. So we have 9 times 0 plus 2 and 9 times 1 plus 2. We can see that this is going to become 2, and that one's going to become 11. Those are the new bounds, and that is the new integral, so we're ready to go.